Hello friends, welcome to Diamond Academy. In the last lecture we have discussed up to the problems on the gradient. Okay, so we have started the discussion on the module of gradient, divergence and curl. Okay, under this we have total 15 topics. Okay, so up to last lecture we have discussed up to the problems on the gradient. Okay, so in this particular lecture we will start discussing divergence of vector point function onwards. So first we will discuss the divergence of vector point function. After that we will discuss definition of divergence, theorem on divergence, definition of solenoidal vector, definition of curl of a vector point function, theorem on curl of a vector point function, what is definition of a irrotational vector, Laplacian operator, Laplace equation, and at last we will start discussing problems on the divergence and curl. So let's start our discussion. So first we have to discuss divergence of a vector of point function. Okay, so let us recall our discussion on the gradient. Okay, so we have discussed in case of a gradient of a scalar point function. Okay, so first we have to note that the gradient always applies on a scalar point function, while divergence divergence applies on vector point function. Okay, so the gradient of a scalar point function gives vector point function vector point function. Okay, and the divergence applies on a vector point function and the result is a scalar point function. Okay, so the gradient of f, let us consider f as a scalar point function. The gradient of f gives a vector point function, and divergence of f divergence of f. Okay, so gradient of f, so f is a scalar point function, scalar point function, and here divergence of f, so f is a vector point function, and the result of divergence of f after application of divergence on vector point function, the result is scalar point function. Okay, so this we have discussed in detail in the last lecture. Okay, so let us start the discussion on the divergence. Okay, so let us write down, let v be a differentiable differentiable vector point function, divergence divergence of v is given as divergence of v or del dot v. Okay, this is del dot v or divergence of v. This is divergence of a vector point function. So let us consider the vector point function v as v1 I cap plus v2 j cap plus v3 k cap. Okay, then divergence of v vector is equal to del dot v. Okay, so this is equal to I del upon del x plus j del upon del y plus k del upon del z. Let us apply this on the vector point function. The vector point function is v1 I cap plus v2 j cap plus v3 k cap. Okay, so this we can expand as, let us take dot product. So the product I cap and I cap dot product is 1. So this is del v1 upon del x plus del v2 upon del y plus del v3 upon del z. So this is the divergence of f. Okay, so point here we have to note is that the divergence of divergence of vector point function vector point divergence of vector point function is a scalar point function. Okay, because the result of this is a scalar quantity, not a vector quantity, scalar quantity. While in case of gradient of, suppose f is a scalar point function, because gradient applies on scalar point function, the gradient of a scalar point function is a vector quantity. Okay, so let us move on further. This we have already discussed. Theorem, if v is equal to v1 I cap. Okay, so how we can prove this? So we have v vector as v1 I cap plus v2 j cap plus v3 k cap. Okay, then divergence of v we have to find. So divergence of v is del dot v, and vector differential operator. So this is I del upon del x plus j del upon del y plus k del upon del z. So let us apply the divergence on the vector point function, and the vector point function is this one. So this is v1 I cap plus v2 j cap plus v3 k cap. Okay, so from here we have del v1 upon del x plus del v2 upon del y plus del v3 upon del z. This is the divergence of a vector point function. Okay, so now definition of a solenoidal vector. What is the definition of this? What is the definition of this? Let v be a vector point function, then v is solenoidal. V is solenoidal vector if divergence of v is equal to 0. Okay, so divergence of v we can write as, suppose v1 is v vector is equal to v1 I cap plus v2 j cap plus v3 k cap. So from here we have del v1 upon del x plus del v2 upon del y plus del v3 upon del z is equal to 0. This is the divergence of a vector point function. Okay, definition of curl of a vector point function. Curl of vector point function. Curl of vector point function. Okay, so let us consider v as a vector point function. V is a vector point function. So let us consider the v vector as v1 I cap plus v2 j cap plus v3 k cap. Okay, so we have the curl of a vector point function. The curl of, let us consider the f. Let us take this as f. Let f be a vector point function. Okay, f be a vector point function. Let f is equal to f1 I cap plus f2 j cap plus f3 k cap. Okay, so we have curl of f. Curl of f is equal to del cross f is equal to. So let us represent this in a determinant form. Okay, so we have I, j and k. So we have the component. Let us represent the components of first vector and the second vector. So we have the component of first vector as I del upon del x plus j del upon del y plus k del upon del z. So these are the components: del upon del x, del upon del y, del upon del z. So let us write down here. So del upon del x, del upon del y, del upon del z, and this is f1, f2 and f3. So let us expand this. So we have del cross f as, this is curl of a vector point function. So curl always applies on a vector point function. Okay, this is I cap, so this is del f3 upon del y. So let us do the cross multiplication. So del f3 upon del y minus del f2 upon del z. Okay, plus j cap. This is del f1 upon del z minus del f3 upon del x plus k cap. This is del f2 upon del x minus del f1 upon del y. So this is the curl of a vector point function. Okay, so note here is that curl always applies on vector point function, and the result is always a vector point function. Okay, so let us summarize this. So we have type, okay, apply type of operator. Okay, it is applies on, or this is result. Okay, so first one is, okay, so let us take first one is gradient, second one is divergence, third one is curl. Okay, so gradient, so we have first one is gradient. So it applies on, किस पे अप्लाई होता है, ये अप्लाई होता है स्केलर पॉइंट फंक्शन, स्केलर पॉइंट फंक्शन, इसको यहाँ लिख दो नोटेशन। ओके, स्केलर पॉइंट फंक्शन पे अप्लाई होता है। डाइवर्जेंस किस पे अप्लाई होता है? वेक्टर पॉइंट फंक्शन, वेक्टर पॉइंट फंक्शन। कर्ल किस पे अप्लाई होता है? वेक्टर पॉइंट फंक्शन। एंड द रिजल्ट ऑफ दिस इज on application of gradient on scalar point function, the result is a vector point function, vector point function. On application of divergence on vector point function, the result is scalar point function, scalar point function. On application of curl on vector point function, the result is a vector point function, vector point function. So the gradient of f is equal to del f, divergence of f is equal to del dot f. Okay, so this is a scalar quantity and this is a f is a vector point function. Curl of f, curl of f is equal to del cross f. F is a vector point function. So here f is a scalar, here f is vector point function, and in the last case, in case of a curl, this is a vector point function. Okay, so let us move on. So this we have already proved. Curl of f is given by these particular expressions. Okay, so now we have definition of irrotational vector. So let f be a vector point function, vector point function, then f is called f is called f is called irrotational vector, irrotational vector if curl of f is equal to 0. That is, del cross f is equal to 0 implies f is an irrotational vector, irrotational vector. अगर कर्ल ऑफ एफ 0 हो जाएगा तो हम क्या कर देंगे? f is a irrotational vector. Okay, so let us move further. So let us discuss the Laplacian operator. Okay, so the Laplacian operator, Laplacian operator is represented as is represented as del square. Okay, so del square we can write as del dot del. Okay, so this is equal to I del upon del x plus j del upon del y plus del upon del z dot I del upon del x plus j del upon del y plus k del upon del z. This is equal to del square upon del x square plus del square upon del y square plus del square upon del z square. Okay, so the del square is equal to del square upon del x square plus del square upon del y square plus del square upon del z square. So this Laplacian operator can be applied on either on a scalar point function or vector point function. So this can be applied on a scalar point function or vector point function, okay. So del square f. Okay, so if f is a scalar point function, then del square f is equal to scalar quantity, okay. And if f is vector point function, then del square f is equal to vector quantity, okay. So del square f we can write as del 2f upon del x square plus del 2f upon del y square plus del 2f upon del z square. Okay, so if f is a scalar point function, then del square f is a scalar quantity. If f is a vector point function, then del 2f is a vector quantity. Okay, so let us move further. So we have Laplace equation. So how we can represent Laplace equation? So the equation del square f is equal to 0 is known as Laplace equation. As simple as that. And the function which satisfies this equation is known as harmonic function. The function which satisfies Laplace equation is known as harmonic function. Okay, so let us start discussing problems on this. So let us discuss question number 1, how we can solve this. So we have this as the divergence of R. We have to prove that the divergence of R is equal to 3. Okay, so let us consider the R vector as x I cap plus y j cap plus z k cap. Okay, so we have the divergence of R as divergence of R vector as del dot R. So this we can write as the del operator as I del upon del x plus j del upon del y plus k del upon del z dot product with R vector. Okay, so we have this as I dot del r upon del x plus j dot del r upon del y plus k dot del r upon del z. Okay, so from here we have del r upon del x as I cap, del r upon del y as j cap, and del r upon del z as k cap. So we have this as I cap dot I cap plus j cap dot j cap plus k cap dot k cap. Okay, because the value of del r upon del x is I cap, value of del r upon del y is j cap, del r upon del z is k cap. So using vector properties, we have this as I dot I is 1 and j cap dot j cap, this is also 1 and this is also 1. So this is equal to 3. So we have the divergence of R vector as 3. Okay, so let us discuss question number 2, how we can solve this. Okay, so we have the curl of R. Curl of R vector is equal to del cross R vector. This is cross product of del operator with R vector. So let us consider the R vector as x I cap plus y j cap plus z k cap. So we have this as curl of R vector is equal to del cross R. So this is equal to I, j and k, and this is let us place the first vector. So this is first vector is Lagrangian operator, that is del operator, and R vector is this one. So let us place the components of the del operator. So this is del upon del x, del upon del y, and del upon del z, because we have the del operator as del upon del x I cap plus j cap of del upon del y plus k cap of del upon del z. So these are the components of the um, del operator. So we have the components of del upon del x, del upon del y, del upon del z, and we have the R vector as x, y, and z. Okay, so this is equal to I times of, let us do the cross multiplication. So this is del y upon del z minus del y upon, sorry, this is del z upon del y, I times of, let us write down here. So curl of R is equal to I times of the cross multiplication. So this is del z upon del y minus del y upon del z plus k cap. This is, sorry, this is j cap. J cap times of del x upon del z, del x upon del z minus del z upon del x plus k cap. This is del y upon del x minus del x upon del y. Okay, so we have del z upon del y is 0. This is I cap. This is 0 minus del y upon del z 0 plus j cap. Del x upon del z is 0 and del z upon del x is 0 plus k cap. Del y upon del x. Okay, this is partial differentiation. So there is no term of x in this. So this is 0 and this is 0. So this is 0. So the curl of R is 0 vector. Okay, this is curl of R. So let us discuss question number 3, how we can solve this. So we have the value of f as, where it is vector point function. So this is x square y I cap minus 2xz j cap plus 2yz k cap. Okay, so from here we have the divergence of f is equal to del dot f. So this is equal to I times of del upon del x plus j times of del upon del y plus k cap del upon del z dot product with f vector. So this is x square y I cap minus 2xz j cap plus 2yz k cap. So this is equal to I dot, this is um, del upon del x of x square y. So this is 2xy and this is I cap, and I cap dot I cap is 1. Similarly, this is j cap dot, this is del upon del y of this one, del upon del y. So this is 0, 0 j cap plus k cap times of, this is dot product to del upon del z with this one. So this is 2y, 2y k cap. So this is equal to, I cap dot I cap is 1. So this is 2xy, and this is 2y plus 2y, and k cap dot k cap is 1. So this is equal to 2y of x plus 1. So this is divergence of f. Divergence of f. Okay. Now we have, in the second part, we have to find the curl of f. So let us find this. Now let us find the curl of f. Second part, we have to find curl of f. Curl of f is equal to del cross f vector. Okay. So let us write down the components. This is I, j, and k, and we have the components of del vector is del upon del x, del upon del y, del upon del z, and f vector, components of f vector, this one, and this one. So this is x square y, this is minus 2xz, and this is 2yz. Okay, so let us find this. So we have this as I cap del upon del y of 2yz. So this is 2z, and this is del upon del z of 2x. This is plus of 2x plus j cap. This is 0 del upon del z of this one, x square y, minus this is del upon del x, this is 0 plus k cap, and this is minus 2z del upon del x of minus 2xz. This is minus this is del upon del y or x square y. This is x square. So this is equal to, so the curl of f is, the value of curl of f is, this is 2x plus 2z I cap, and this is minus x square plus 2z k cap. Okay, so this is the value of curl of f. Okay, so now let us find the third part. So we have, in the third part, we have to find the, in the third part we have curl of f. Okay, so we have calculated the curl of f as curl of f. Curl of f we have found in the second part. Okay, so we have the curl of f as curl of is 2x plus 2z I cap minus x square plus 2z k cap. Okay, so this is curl of f. So we have to find curl of f. So we have to find the cross product with curl of f. Okay, so this we can write as I, j, and k, and we will write the components in the determinant. Okay, so we have the first vector as del operator. So let us write down the components. So del upon del x of the components of del operator, del upon del y, del upon del z. Similarly, the components of curl of f. So we have this as the I cap as, the component is 2x plus 2z with respect to I cap. So this is 2x plus 2z, and we have of k cap. So this is minus of x square plus 2z. Okay, so this is equal to I cap. This is del upon del y. This is 0 minus 0 plus j cap. J cap. So we have the del upon del z times of 2x plus 2z. So this is 2, and this is plus del upon del x. So this is 2x plus k cap times of. So this is 0. This is 0 minus 0. So this is equal to 2x plus 2 times of j cap. Okay, so we have the value of curl of f as 2x plus 2 times of j cap. Okay, so let us discuss question number 4, how we can solve this. So we have, in this Question, we have to find the divergence of f and curl of f. So divergence of f is dot product with vector f, dot product of del operator with vector f. So this we can write as, let us take the components. So the components of I is x square plus y square. So this is del upon del x square minus y square plus del upon del y. So this is 2xy. So this is 2xy plus del upon del z, and this is y square minus xy. So this is equal to 2x plus this is del upon del y with respect to 2, this is 2x, and this is del upon del z, so this is plus 0, so this is equal to 4x. So we have the divergence of f as 4x. So let us find curl of f. So curl of f is del cross f. Okay, so this is equal to, so we have the components. Let us write down the components. So we have this as del upon del x, del upon del y, del upon del z, and the vector f has, so let us write down the components. So this is x square minus y square, this is 2xy, and this is y square minus xy. So this is equal to I times of, so del upon del y, and this is x square minus xy. So this is equal to 2y minus x plus j cap. This is 0 minus, this is 0 minus of this is plus, so plus y plus k cap. This is 2y, and this is plus 2y. Okay, so the curl of f, the value of curl of f is 2y minus x curl of f. This is equal to 2y minus xi cap plus yj cap plus 4y k cap. This is the value of curl of f. Let us find the question number. Let us solve question number 5. How we can find this? So we have to find the divergence of f and curl of f. Okay, so divergence of f is equal to del dot f. Let us take the vector f as, so let us expand this del operator. This is I del upon del x plus j del upon del y plus k del upon del z, and dot product with, let us uh, assume that vector f has f1 I cap plus f2 j cap plus f3 k cap. Okay, so this is f1 I cap plus f2 j cap plus f3 k cap. So this we can write as, and for taking the dot product we have I cap dot I cap, this is 1. So we have this as del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Okay, so similarly let us find the value of gradient of this function. Okay, so this is a scalar point function, and gradient is being always applied on scalar point function. So f is equal to, this is I del upon del x plus j del upon del y plus k del upon del z. Okay, so we have to take the del operator with this one, x cube plus y cube plus z cube minus 3xyz. Okay, because we have gradient of any phi is a vector point function. So for taking the gradient of phi, we apply the del operator on that function. Okay, so this is equal to del upon del x of whole function. Okay, so we have to take del upon del x of this whole function. So this is 3x square minus 3yz I cap plus j cap. This is 3y square minus 3xz plus k cap del upon del z of this one. This is 3z square minus 3xy. Okay. Okay, so this is our function f. This is our function f. So we have to find the divergence of f. So divergence of f is del dot f. Okay, so the del dot f we can take as del upon del x of 3x square minus 3yz plus del upon del y. This is 3y square minus 3xz plus del upon del z. This is 3z square minus 3xy. So this is equal to 6x plus this is 6y and this is 6z. So this is equal to 6x plus y plus z. Okay. So this is our um, divergence of f. Now we have to find the curl of f. Okay. So how we can find this? So let us we have the value of f as this one. This is value of f. Okay. So let us write down the represent curl of f. So curl of f, for finding the curl of f, we represent this in a um, deterministic form. Let us write down the determinant. So we have the curl of f as del cross f. So this is equal to I, j and k. This is del upon del x, del upon del y. This is del upon del z. And the f vector is this one. So this is 3x square minus 3yz. And this is um, 3y square minus 3xz. And this is 3z square minus 3xy. Okay. Now let us find this. Let us expand this for finding the value of curl of f. This is equal to I times of, this is del upon del y of this one. So this is equal to minus 3x. And this is del upon del z. So this is equal to plus 3x plus j cap times of, this is minus 3y. And this is plus 3y plus k cap times of, this is minus 3x. And this is, sorry, this is k cap times of, this is minus 3x, sorry, minus 3z. This is minus 3z. And this is plus 3z. Okay, so this is 0 I cap plus 0 j cap plus 0 k cap. So this is equal to curl of f is 0 vector. Okay, let us discuss question number 6, how we can find this. So we have the gradient of phi as del of phi. So this is equal to I del upon del x plus j del upon del y plus k del upon del z times of phi. Now phi is, value of phi is 2x square y cube z4. So this is equal to I times of, this is 2x, this is 4x y cube z4 plus j cap. This is 6x square y square z4 plus k cap. This is 8x square y cube z cube. Okay, so this is gradient of phi, gradient of phi. Now we have to find the divergence of gradient of phi. Okay, so this is del upon del x of 4x y cube z4 plus del upon del y of 6x square y square z4 plus del upon del z of 8x square y cube z cube. So this is equal to 4y cube z4 plus this is 12x square y z4 plus this is 24x square y cube z square. This is the value of divergence of gradient of phi. Okay. Okay, so let us discuss question number 7. Let us discuss question number 7. So we have the value of f as f is equal to xy square I cap plus 2x square yz I cap minus 3yz square k cap. Find the divergence of f and curl of f, and what are their values at point 1 comma minus 1 and 1. Okay, so let us find this quickly. This is divergence of f. So this is equal to Let us take the del upon del x with this one. This is y square. Del upon del y with respect to this. This is plus 2x square z. This is del upon del z. This is minus 6yz. Okay, divergence of f. So we have to find divergence of f at 1, minus 1 and 1. So this is equal to 1 plus 2 into 1 into 1. This is minus 6 into y is minus 1 into 1. So this is equal to 1 plus 2 plus 6. This is none. Okay, the value of this is 9. So let us find the curl of f. So we have the, in second part we have to find curl of f. So this is equal to I, j and k, and this is del upon del x, this is del upon del y, this is del upon del z, and this is xy square, this is 2x square yz minus 3yz square. This is curl of f. So this is equal to I times of, this is minus 3z square, and this is minus 2x square y plus j cap. This is 0 minus, this is j cap, this is 0, and this is plus 0. This is k cap. This is 4xyz, 4xyz. This is minus 2xy. Okay, so this is the value of curl of f. Curl of f. Okay, so we have to find the value of curl of f at 1 comma minus 1 and 1. So this is equal to, this is I cap minus 3, and this is plus 2 plus j cap. This is 0 plus k cap. This is 4 times of 1, and this is minus 1 into 1 minus 2 into 1 into minus 1. So this is equal to minus I cap plus 0 j cap plus k cap, and this is 4 times of minus 1. This is minus 4, and this is plus 2. So this is minus 2. So this is equal to minus I cap minus 2k cap. Okay, this is the value of curl of f at point 1 comma minus 1 and 1. So let us discuss question number 8. How we can find this? Okay, so this is similar to previous question. So we have the value of divergence of f at, let us write down the answer. Okay, you can solve this. This is similar to previous question. Okay, so we have the divergence of f at 1 comma minus 1 and 1 as minus 3, and curl of f at 1 comma minus 1 and 1, this is minus 6i. Okay, let us discuss question number 9. Let us discuss question number 9, how we can solve this. So this is the value of f is given as this one. So we have the divergence of f as del of f1 upon del x plus, let us take this as f1, this as f2, and this as f3. Okay, so this is plus del f2 upon del y plus del f3 upon del z. So this is equal to del f1 upon del x, this is minus 2x, del f2 upon del y, this is minus 2y, and del f3 upon del z is minus 2z. Okay, so we have this as, this is equal to minus 2x plus y plus z. Okay, now let us find curl of f. Curl of f, how we can find this? So this is I, j and k. Let us write down the value. This is del upon del x, this is del upon del y, this is del upon del z. So let us place the values here. So this is y square plus z square minus x square. Okay, the component, second component is z square plus x square minus y square, and this is third component, x square plus y square minus z square. So this is equal to I cap times of del upon del y, this is 2y, and this is minus 2z plus j cap, this is 2z, this is minus 2x plus k cap, this is 2x, this is minus 2y. Okay, now let us write down this. So this is equal to This is equal to 2 times of y minus z I cap plus 2 times of z minus x j cap plus 2 times of x minus y k cap. So this is the value of curl of f. Okay. Now let us discuss question number 10. How we can find this? This is f dot curl of f. So we have the curl of f as this is I, this is j, and this is k. So this is equal to del upon del x, del upon del y, del upon del z, curl of f. So this is equal to x plus y plus 1. This component of j cap is 1, and the third component is this one. This is minus x minus y. Okay, let us take the cross product. So we have I cap. So let us take the cross product. This is minus 1. This is del upon del z of 0. So this is minus 0 plus j cap. This is 0 minus, this is minus of minus 1 plus k cap. This is 0 minus 1. So this is minus I cap plus j cap, and this is minus k cap. This is curl of f, curl of f. So now we have f dot curl of f. Okay, so let us take the dot product with this. So we have this is equal to, we have to take the dot product with this one, curl of f. So we have this as minus of x plus y plus 1, and this is component of j cap is 1. So this is plus 1, and this is component of k cap is minus 1. So the minus 1 times plus minus 1 times minus x minus y. So this is equal to minus x minus y minus 1. This is plus 1. This is plus x plus y. This is equal to 0. ठीक है. Now let us find question number 11. How we can find this? So we have the gradient of u. So gradient of u is equal to now I del upon del x plus j del upon del y plus k del upon del z times of u. So this is 3x square y. So this is equal to 6x y. Okay, I cap 6xy I cap plus 3x square j cap plus del upon del z of this one. This is 0 k cap. Okay, so this is gradient of u. So we have, and we have gradient of v as, so this is equal to I del upon del x plus j del upon del y plus k del upon del z times of, this is x z square minus 2y. So this is equal to z square, this is x na, so this is z square I cap minus 2j cap plus del upon del z of this one. So this is plus k cap, and this is del upon del z. So this is 2xz. Okay, this is gradient of v. So gradient of v is z square I cap minus 2j cap plus 2xz k cap. Okay, so now let us find the value of gradient of u dot this one. So this is gradient of u dot gradient of v. So the gradient of u dot gradient of v, gradient of u. So this is equal to 6x yz square, and this is minus 3x square times of 2. So this is minus 6x square plus 0. So this is equal to 6xyz square minus 6x square. Okay, now let us take the gradient of u dot gradient of v. Okay, so this is equal to gradient of, so this is, let us take the del operator, I del upon del x plus j del upon del y plus k del upon del z times of This is 6xyz square minus 6x square. So this is equal to, let us take del upon del x with this one. So this is 6yz square minus 12x plus j cap times of, this is 6xz square plus k cap times of, k cap times of, this is 12xyz. Okay, so this is equal to, this is I cap. This is j cap. Okay, so this is answer. 6xz square minus 12x I cap plus 6xz square j cap plus 12xyz k cap. Okay, let us discuss question number 12. How we can solve this? So we have um, del square u. Del square u is equal to del 2 u upon del x square plus del 2 u upon del y square plus del 2 u upon del z square. Okay, so we have del u upon del x as 2x and del 2 u upon del x square is equal to 2. Now del u upon del y is equal to minus del u upon del y. So let us take differentiation with respect to y. This is minus 2y. So del 2 u upon del y square is equal to minus 2. Del u upon del z, this is equal to 4, and del 2 u upon del z square is equal to 0. So this is equal to 2 minus 2 plus 0 is equal to 0. Okay. Now let us discuss question number 13. How we can find this? So we have the value of f as this one. Show that del dot f is equal to del f1 I cap plus del f2 j cap plus del f3 k cap. So let us find del f1. What is del f1? So del f1 is I del upon del x plus j del upon del y plus k del upon del z times of f1. Okay. So this is equal to I times of del f1 upon del x plus j times of del f1 upon del y plus k times of del f1 upon del z. Okay, so this is the value of del f1. So let us find this one first. Del f1 dot I cap. Okay, so del f1 dot I cap. So let us take dot product of I cap with this one. So this is equal to del f1 upon del x. Similarly, del f2 with j cap. So this is equal to uh, del f2 upon del y. Okay, and del f3 with k cap. This is equal to del f3 upon del z. Okay, so let us place these values in this one. So we have del f1 dot I cap plus del f2 dot j cap plus del f3 dot k cap. So this is equal to del f1 dot I cap is this one. So this is equal to del f1 upon del x. Similarly, this is del f2 upon del y plus similarly this is del f3 upon del z. Okay, this is nothing but divergence of f. Okay, on expanding this, suppose we have the value of, so value of f is given as f1 I cap plus f2 j cap plus f3 k cap. Okay, so the divergence of f is this one. If you take the dot product, we will get this value. Okay, now let us discuss question number 14. How we can solve this? Okay, so let us solve this. So we have del dot r cube of r vector is equal to 6r cube. Okay, so this we have to show. Okay, so let us take the r vector as x I cap plus y j cap plus z k cap. Then we have del dot r cube of r vector is equal to I del upon del x plus j del upon del y plus k del upon del z dot r cube. Let us represent r as x I cap plus y j cap plus z k cap. So this is equal to del upon del x of r cube or x plus del upon del y of r cube y plus del upon del z of r cube z. Okay, so this we can expand further. Okay, so let us expand this by differentiation under parts. Okay, so this is equal to r cube plus x times of 3r square del r upon del x. Expand this plus this is r cube plus y times of 3r square del r upon del y plus let us expand this. So this is r cube plus z times of 3r square del r upon del z. Okay, so we have r square is equal to x square plus y square plus z square. So from here we have 2r del r upon del x is equal to 2x. So from here del r upon del x is equal to x upon r. Similarly, del r upon del y is equal to y upon r. Similarly, del r upon del z is equal to z upon r. So let us combine this. So we have r cube and r cube. So this is 3r cube plus this is 3r square. From here we have x del r upon del x plus y del r upon del y plus z del r upon del z. Okay, so this is equal to 3r cube plus 3r square into x times of del r upon del x is x upon r plus y times of y upon r plus z times of z upon r. So this is equal to 3r cube plus 3r square upon r into x square plus y square plus z square. So this we can write as r square. This we can write as r square. Okay, so this gets cancelled. So we have this as 3r cube plus 3r cube. This is 6r cube. Okay, let us discuss question number 15. How we can solve this? I will give the hint. Okay, so find the constant a, b and c so that the vector f is irrotational. So the condition for the irrotational vector is curl of f. Curl of f, that is del cross f, is equal to 0. Okay, so let us take this as f1, this as f2 and this as f3. Okay, so let us represent del cross f as, so this is equal to components of first vector and second vector. So let us represent this in a determinant. This is I, j and k. So this is a component of first vector. So this is del upon del x, del upon del y, del upon del z. And the component of second vector is f1, f2 and f3. So this is equal to I, j and k. And this is del upon del x, del upon del y, del upon del z. And f1 is x plus 2y plus az. And this is f2. f2 is bx minus 3y minus z. And this is 4x plus cy plus 2z. Okay, so let us expand using cross multiplication. So this is equal to I times of, this is del upon del y of this one. So this is c. Okay, and this is del upon del z of this particular expression. So this is plus 1 plus j cap. So this is del upon del z of this one. So this is a, and minus del upon del x. This is 4 plus k cap. This is del upon del x of this. So this is b and minus 2. So this is equal to, this is a irrotational vector. Okay, so we have to find the constant a, b and c such that the vector f is irrotational. So this we can equate with 0 vector. So this is 0 I cap plus 0 j cap plus 0 k cap. So let us equate this. So c plus 1 is equal to 0 implies c is equal to minus 1. A minus 4 is equal to 0. This implies c is equal to 4. And b minus 2 is equal to 0 implies b is equal to 2. Okay. Now let us discuss question number 16. How we can solve this? So for a solenoidal vector, we have v is said to be a solenoidal. Okay, so the vector v is said to be a solenoidal if divergence of v is equal to, 0. Then we can say that the vector v is solenoidal vector. So let us find the divergence of v. So divergence of v is equal to, let us take v as v1 I cap plus v2 j cap plus v3 k cap. So we have studied earlier that divergence of v is del v1 upon del x plus del v2 upon del y plus del v3 upon del z. Let us find this. So del v1 upon del x. So this is our v1, this is v2 and this is v3. Okay, so del v1 upon del x is 1 plus del v2 upon del y. So del v2 upon del y, this is 1 plus del v3 upon del z. So this is a. So divergence of v is equal to. Okay, so this is a plus 2. And this is since it is given in the question that v is a solenoidal vector. So this is equal to 0. So from here a is equal to minus 2. Okay. Now let us discuss question number 17. Show that the vector v is irrotational. So let us take this as f1, this as f2, sorry, this as v1, v1, v2, and this is v3. Okay, so for irrotational vector, we have del cross v is equal to 0. So from here we have del cross v is equal to, this is I, j, and k. Let us represent the components of first vector and second vector. So this is del upon del x, del upon del y, this is del upon del z, and this is second vector is this one. So v1 is sin y plus z, and this is x cos y minus z, and this is x minus y. So let us expand this. So let us write down the components of I cap. So we have this as del upon del x times of this. So this is cos y, sorry, this is, we have to take the cross multiplication. This is equal to I vector. So this is cross multiplication. So for I cap we have del upon del y of this one. So this is minus 1, and this is minus times of, this is x cos y minus z. So this will be minus of minus 1. Okay, so this is plus 1 plus j cap. This is 1. Or minus del upon del x of x minus y. This is 1 plus k cap. This is del upon del x of, this is cos y. And this is del upon del y of sin y plus z. This is minus cos y. Okay, so this is equal to 0 I cap plus 0 j cap plus 0 k cap. That is 0 vector. Hence we can say that since curl of v is equal to 0, since curl of v is equal to 0, then v is a irrotational. Irrotational vector. Okay, so let us discuss question number 18, how we can solve this. Okay, so divergence of v, let v is a vector, constant vector. Okay, so v is a constant vector. So let us take v as, v is a constant vector. So let us take v as v1 I cap plus v2 j cap plus v3 k cap. Okay, so since v is a constant vector, then v1, v2 and v3 are also constants, as v is a constant vector. Okay, so divergence of v we can write as divergence of v is equal to del v1 upon del x plus del v2 upon del y plus del v3 upon del z. So since v1, v2 and v3 are constant, so this is equal to 0. Let us find curl of v. So curl of v we can write as curl of v is equal to I, j, and k. This is del upon del x, del upon del y, del upon del z, and this is, let us represent the components. So this is v1, v2 and v3. So this is equal to I cap of del v3 upon del y minus del v2 upon del z plus j cap. This is del v1 upon del z minus del v3 upon del x plus k cap. This is del v2 upon del x minus del v1 upon del y. Okay, so v3 is constant, then del v3 upon del y is 0. v2 is constant, then del v2 upon del z is 0. v1 is constant, then this del v1 upon del z is 0. v3 is constant, so del v3 upon del x is 0. v2 is constant, therefore del v2 upon del x is 0, and v1 is constant, then this is also 0. So this is equal to 0 I cap plus 0 j cap plus 0 k cap. Okay, let us discuss question number 19, how we can solve this. Okay, so if a is a constant vector, so let us take a as, so let a vector is a1 I cap plus a2 j cap plus a3 k cap. Okay, so we have to find the divergence of r cross a. So we have the r cross a vector. Let us find r cross a vector. So let us take r vector as x I cap plus y j cap plus z k cap. So r cross a is, this is I, j and k. So we have r vector as x, y and z, and a vector as a1, a2 and a3. Okay, so let us expand this. So we have this as I cap. Let us write down the components of I cap. So this is y, a3y minus a2z. So this is a3y minus a2z plus j cap. This is a1z minus a1z. This is j cap. a1z minus a3x plus k cap. This is a2x minus a1y. Okay, so this is r cross a. So divergence of r cross a is equal to, okay, so let us take this as, this will be equal to del upon del x of a3y minus a2z plus del upon del y of this term. This is a1z minus a3x plus del upon del z of a2x minus a1y. Okay, so this is equal to, there is no term of x here, so this is 0. There is no term of y here, so this is 0. There is no term of z here, so this is 0. So this is equal to 0. So the divergence of r cross a, where r is a constant vector, is equal to 0. Okay, so this we have written as, because we have studied the divergence of v is equal to, suppose v is equal to v1 I cap plus v2 j cap plus v3 k cap. So directly we can write as divergence of v is del v1 upon del x plus del v2 upon del y plus del v3 upon del z. So similarly, let us take this as v1 and this as v2 and this as v3. Okay, so we have taken the differentiation of this particular term, that is v1 with respect to del x, similarly for del y and del z. Okay, so now let us find curl of r cross a. Okay, second, curl of r cross a. So we have the a vector as a1 I cap plus a2 j cap plus a3 k cap. Okay, and r vector is x I cap plus y j cap plus z k cap. So from here, curl of r cross a, this is equal to, let us find r cross a first. R cross a, so this is equal to I, j and k, and r vector, components of r vector x, y and z, and component z vector a1, a2 and a3. So this is equal to I times of a3y minus a2z plus j times of a1z minus a3x plus k times of a2x minus a1y. Okay, this is r cross a. So curl of r cross a, curl of r cross a is equal to I, j and k. So this is del upon del x. So this is equal to del cross r cross a. So let us represent the components of del vector and r cross a vector. So this is del upon del x, del upon del y, this is del upon del z, and we have the components of r cross a vector as this one. So this is a3y minus a2z, this is a1z minus a3x, and this is a2x minus a1y. Okay, so this is equal to I times of, this is del upon del y of this one, so this is minus a1, and this is minus a1 plus j times of, this is del upon del z of this one, so this is minus a2 minus, this is a2 plus k times of, this is del upon del x of this one, this is minus a3 and minus a3. Okay, so this is equal to I cap, this is minus 2a1, this is plus j cap, this is minus a2, 2a2 sorry, plus k cap, this is minus 2a3. Okay, so this is equal to, this is equal to, so we have del cross r cross a vector is equal to minus, let us take minus 2 common, so this is a1 I cap plus a2 j cap plus a3 k cap. So this is equal to minus 2a. Okay, so this is equal to 0. Answer is 0, and this is curl of r cross a is minus 2a. Okay, so let us discuss question number 20. So we have the curl of v. Curl of v is equal to, this is I, j and k. So curl of V is del cross V. Okay, so we have let us write down the components of first vector and second vector. So this is vector differential operator. So this is del upon del x. The components are del upon del x, del upon del y, del upon del z. And in second case, the components with respect to I, j and k are e to the power x, y, z. This is e to the power x, y, z, and this is e x, y, z. Okay. So let us expand this. So we have curl of V is equal to I cap del upon del y of e to the power x, y, z minus del upon del z of e to the power x, y, z. Okay. Plus j cap. This is del upon del z of e to the power x, y, z minus del upon del x of e to the power x, y, z plus k cap. This is del upon del x of e to the power x, y, z minus del upon del y of e to the power x, y, z. Okay, so this is equal to I cap del upon del y. This is e to the power x, y, z into this is x, z minus this is e to the power x, y, z into x, y plus j cap. This is e to the power x, y, z into x, y minus e to the power x, y, z into y, z plus k cap. This is e to the power x, y, z into x, y minus e to the power x, y, z into x, z. Okay, so let us further simplify this. So this is equal to e to the power x, y, z. Let us take common from whole one. Okay, so this is x times of z minus y I cap plus from here y is common, y is common, and e to the power x, y, z we have already taken out. So this is y times of x minus z j cap plus this is x times of y minus z k cap. Okay, so this is value of curl of V. Okay, now let us discuss question number 21, how we can find this. So we have this as we have to find the divergence of f. Okay, so let us take this as f1, this as f2, and this as f3. Okay, so if f1 is f vector is f1 I cap plus f2 j cap plus f3 k cap, then we have divergence of f as del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So this is equal to del f1 upon del x. So this is differentiation of 2x square z with respect to x. This is 4xz. Del f2 upon del y. So this is minus 2xyz and um, del f3 upon del z. So this is 0. So this is equal to let us take 2xz common. So this is 2 minus y. Okay, so this is the value of divergence of f. So let us discuss question number 22. Actually, this is r cube, x upon r cube. Show that del square x upon r cube is equal to 0. Okay, so we have del square x upon r cube is equal to let us expand this. So this is del square, this is Laplacian operator. So this is del square upon del x square plus del square upon del y square plus del square upon del z square. Okay, this Laplacian operator can be applied either on the scalar point function or vector point function. Okay, so this we can find as, so this is x upon r cube is a scalar point function. So this is x upon r cube. So let us expand this. So let us find first term first. So del square upon del x square of x upon r cube is equal to del upon del x of x upon r cube. Okay, so this is let us expand this with parts. So this is del upon del x of, so this is 1 upon r cube plus x times of this is del upon del x of r to the power minus 3. So this is minus 3r minus 4 into del r upon del x. So this is x times of minus 3 upon r4 into del r upon del x. Okay, and del r upon del x is x upon r. This we have already calculated. Let us write down x upon r here. This is x upon r. Okay, so this is equal to del upon del x of 1 upon r cube minus 3x square upon r5. Okay, so let us further simplify this. So this is equal to, let us expand this. So this is minus 3 upon r4 into del r upon del x. So this is x upon r minus, let us expand this also, 3x square upon r5. So 3 times of this is 2x upon r5 plus x square into r to the power minus 5. तो इसका क्या होगा, minus 5 r minus 6. So this is minus 5 upon r to the power 6 into del r upon del x. So this is x upon r. Okay, so this is equal to, let us further simplify this. On expanding this, this is equal to minus 3x upon r5, and from here we have minus 6x upon r5. So this is equal to minus 9x upon r to the power of 5 plus, and this is 5 3 is 15. So this is 15x cube upon, this is r to the power 6 and r. So this is r to the power of 7. Okay, so similarly, del square upon del y square of x upon r cube. This is equal to minus 3x upon r5 plus 15x z square upon r7. And similarly, del square upon del z square of x upon r cube is equal to minus 3x upon r5 plus 15 15x z square upon r to the power 7. This actually, this is y square. Okay, so this is the value of del upon del 2 upon del x square of x upon r cube. Okay, so del 2 upon del x square of x upon r cube is this particular term, minus 9x upon r5 plus 15x cube upon r7. Okay, similarly, del 2 upon del y square of x upon r cube, this is minus 3x upon r5 plus 15xy square upon r to the power 7. And del 2 upon del z square x upon r cube, this is minus 3x upon r5, 15xz square upon r7. So let us combine this. Let us add all these three expressions for getting the answer. Okay, so del 2 upon del x square of this one. So this is minus 9x upon r5 plus 15x cube upon r7 plus, this is minus 3x upon r5 plus this. So this is minus 3x, this is minus 3x upon r5 plus 15xy square upon r7 plus, this is minus 3x upon r5 plus 15xz square upon r7. Okay, so let us further simplify this. So this is equal to minus 9x 9, and this is 6 minus 15x upon r5 plus, this is 15 upon r7, and this is x. Let us take x common. So this is x square plus y square plus z square. So this is equal to minus 15x upon r5 plus 15x upon r7 into r square. So this is equal to minus 15x upon r5 plus 15x upon r5. This is equal to 0. Okay, so we have discussed all the questions on the divergence and curl. Okay, thank you.